Every day, you interact with machine learning without even realizing it. Netflix recommends movies you'll probably enjoy. Gmail filters spam emails automatically. Google Maps predicts traffic before you leave home. But how do computers make these decisions? In this video, you'll learn the fundamentals of machine learning, how it works, its different types, and where it's used in the real world. Machine learning is a branch of artificial intelligence that enables computers to learn patterns from data instead of relying solely on explicitly written rules. In traditional programming, developers write every instruction. In machine learning, we provide data and expected outcomes, allowing the algorithm to discover the patterns automatically. Once trained, the model can make predictions on new data it has never seen before. Some problems are too complex to solve with thousands of manually written rules. Imagine trying to write rules that identify every spam email or every fraudulent banking transaction. Instead, machine learning learns from historical examples and continuously improves its predictions. Every machine learning project follows a similar process. First, data is collected from sources such as databases, applications, sensors, or APIs. Next, the data is cleaned by removing duplicates, handling missing values, and correcting inconsistencies. The clean data is then used to train a machine learning model. After training, the model is evaluated using data it hasn't seen before to measure its accuracy and reliability. Finally, the model is deployed into an application where it can make predictions on new data. Supervised learning uses labeled data, meaning the correct answers are already known during training. The goal is to learn the relationship between inputs and outputs. Common applications include predicting house prices, detecting spam emails, forecasting sales, and identifying diseases from medical data. Unsupervised learning works with unlabeled data. Instead of predicting known answers, it discovers hidden structures and patterns. Businesses use it for customer segmentation, anomaly detection, and recommendation systems. Reinforcement learning teaches an agent through trial and error. The agent receives rewards for good decisions and penalties for poor ones. Over time, it learns the best strategy. This approach powers robotics, autonomous vehicles, and game-playing AI systems. Different problems require different algorithms. Linear regression predicts continuous values, such as sales or prices. Logistic regression is commonly used for binary classification problems. Decision trees and random forests are popular because they are easy to understand and perform well on many business problems. K-means is widely used for clustering similar data points. Neural networks are the foundation of many modern AI systems, including image recognition and language models. Machine learning is transforming almost every industry. In healthcare, it assists doctors by identifying diseases from medical images. Banks detect fraudulent transactions in real time. Retail companies recommend products and forecast demand. Manufacturers use predictive maintenance to reduce equipment failures. Streaming platforms recommend movies and music based on viewing habits. Machine learning is powerful, but it isn't magic. A model is only as good as the data used to train it. Poor quality or biased data can produce inaccurate or unfair predictions. Models can also overfit, meaning they memorize training data instead of learning general patterns. Privacy, security, and ethical considerations are also critical when working with sensitive information. Artificial intelligence is the broad field of creating systems that perform tasks requiring human intelligence. Machine learning is a subset of AI where systems learn from data. Deep learning is a specialized area of machine learning that uses neural networks with many layers to solve highly complex problems, such as image recognition, speech processing, and large language models. You now understand the core concepts of machine learning and how models learn from data. In the next videos, we'll move into hands-on implementation using Python. We'll start with essential libraries like NumPy, Pandas, and Scikit-Learn, then build practical machine learning projects, including time series forecasting with Facebook Profit. Thanks for watching. If this video helped you understand the basics of machine learning, please Please like, share, and subscribe for more practical AI and software architecture content.